Okay, welcome back to another video on the Math channel. It's your teacher Mr. Lim here, and in this video we are going to evaluate trig expressions using angles of any magnitude and complementary results. So by the end of this lesson you'll be able to do these four things. Draw rays on a coordinate plane or on a number plane to represent any angle. Identify possible angles of any magnitude from rays on a coordinate plane. Write trig ratios from diagrams, and evaluate trig expressions. So let's have a look at the first one. Drawing rays to represent any angle. On a number plane, draw rays representing the following angles: 50 degrees, 120, 200, 280, 430, and 510. So 50 degrees, I'm just going to eyeball this. 50 degrees I would say is about here. Okay, so I'm saying that's 50 degrees. 120 degrees, I would say is probably around there. So I'm saying that's 120 degrees. 200 degrees, probably around here. Okay, so that's 200 degrees. 280 degrees, around there. What about 430 degrees? Okay, if we were to do a full revolution, that's 360, but we need to do another 70 degrees in order to get to 430 degrees. So another 70 degrees is probably around there. So we can draw our straight line. And say that is 430 degrees. $510. If we were to do 510 and minus the 360, that's the same as saying finding 150 degrees. So 150 degrees is probably around here. But instead of labeling it 150 degrees, we label it with the 510. Okay. So now we know how to represent angles that are greater than 360 or 2 pi. What about negative angles? So here we've got negative 40 degrees. If you want to think about it like this, every time we say 70 degrees, for example, positive 70, we're going anti-clockwise by 70 degrees. But here, if we're going negative, we can say we're going the opposite direction. We're going clockwise. Clockwise 40 degrees. Now, I'm not going to actually do it this way. I prefer to just add lots of 360 until I get an angle that's between 0 and 360. So if I were to take my negative 40, add 360 to it, that's the same as saying an angle of 320 degrees. So an angle of 320 is probably around here, because that's about 320 degrees. So I'm going to write negative 40 degrees right there. Alright, what about negative 120? Negative 120 plus 360 is the same as 240 degrees. 240 degrees is probably around here, but I'm just going to label that as negative 120 degrees. What about negative 200? Negative 200 plus 360 is 160. 160 degrees, probably around here. Just going to label that with negative 200 instead. What about negative 280? $80 degrees. I'm just going to label it as negative 280 degrees. Okay, because that's technically 80 degrees. Well, what about negative 430? So if I were to do negative 430 and add 360, I'll still get a negative answer. So I can just add 360 again, and that will give me 290 degrees. So 290 degrees is probably around here. I'm just going to label that as negative 430. Same with the 510. Negative 510 plus 360 will still be negative, so I'm going to add another 360, 210 degrees. 210 degrees is around here, and because that's 210. And I will label that negative 510 degrees. Okay. So now that we know how to do that, let's have a look at how to identify possible angles of any magnitude. So we're going to write down two positive angles between 0 and 720, and two negative angles between negative 720 and 0 that are represented by each of the rays in the diagram below. So I think it's just easiest for me to just go through the most obvious ones for each of them. So we know A, that's 70 degrees. B is 90 plus 10, 100 degrees. C is 270 minus 30, which is 240 degrees. And D is 360 minus 20, or 340 degrees. Okay, so those are the most obvious ones, and for the positive, and they all lie between 0 and 720. So if I want to just write down another possible angle that is positive, I can just add 360 to all of them. 70 plus 360 is 430. 100 plus 360, 460. 240 plus 360, 500. Sorry, 600. And 340 plus 360 is 700. Okay, and yes, they all lie between 0 and 720. What if we want the negative answers? Okay, the negative angles. What I could do is I could take that 70 and I would minus 360 this time, because this is exactly the same angle. So 70 minus 360 is negative 290. And then I'll just minus 360 again to get another negative angle, negative 650. Okay. Maybe pause the video, have a go with B, C, and D, and when you're ready to check your answers, continue playing the video. Okay, and here are the answers. Alright, let's move on. Let's have a look at how to use diagrams to write trig ratios. So here we've got something like a unit circle, except we don't know what the radius is, so we'll just call it r. Sine of theta, we'll just label this hypotenuse, opposite, adjacent. Sine of theta is opposite over hypotenuse, which in this case is y on r. Therefore, cosec of theta, because we know cosec of theta is 1 on sine theta, or we can just flip the fraction, will be hypotenuse over opposite. That's equal to r on y. Cos of theta is adjacent over hypotenuse, which is x on r. Whereas secant theta is equal to hypotenuse on adjacent, because it's 1 on cos, so we're just going to flip the fraction. Hypotenuse on adjacent, which is r on x. Tan theta is equal to opposite over adjacent, which in this case is y on x. Cotangent theta is therefore equal to the reciprocal, adjacent over opposite, which is x on y. Okay, So let's write the 6 trig ratios of the angle theta in each of the diagrams below. So I'm just going to continue. I'm just going to make my right angle triangle. We know that this point here is 6, 8. That means x is 6, y is 8. So if I want to find sine, and we know that because the radius here says it's 10, the hypotenuse has to be 10 as well, because it's also a radius. So, sine of theta. Let's just assume that theta is in each of these. Okay. Sine theta is equal to opposite over hypotenuse, 8 over 10, which is 4 and 5. Cos of theta is equal to adjacent over hypotenuse, 3 and 5. And tan theta is equal to opposite over adjacent, 8 over 6, or 4 and 3. So if I want to find cosec theta, I just flip that for the sine. If I want to find secant theta, 5 and 3. Cotangent theta, 3 and 4. Okay, all we're doing is we're finding the reciprocal. Alright, what about B? We know x is minus 12, y is 5. We shouldn't use minus 12, it's 12, because you can't have a negative length. And the hypotenuse is 13, because the radius is 13. Okay, so these are the coordinates. That's why it says it's negative 12, because on the Cartesian plane, that's where minus 12 is. So, sine. Because remember that this here, which we can call alpha, is a reference angle for theta. So we're going to get the same angle anyway. So sine of theta is equal to opposite over hypotenuse. And it's important to remember all stations to central. So sine is positive here. Cos of theta is equal to adjacent over hypotenuse. But here only sine is positive, so this is negative. And tangent theta is equal to opposite over adjacent. And again, this is negative. Therefore, if we were to find the reciprocal trig functions, or trig ratios, cosec or cosecant theta, or equal to 13 on 5. Secant theta, or equal to negative 13 on 12. And cot or cotangent theta is equal to negative 12 on 5. Okay, so pause the video, have a go with question C and D, and then continue playing the video to check your answers. Okay, so here are my answers for C and D. Alright, let's move on to the last section of this video. Evaluating trigonometric expressions. Okay, so here we've got the unit circle, because we need to make sure that we know how to do these for exact values as well. So we've got sine of 405. What is 405? The same as in degrees. It's 45 degrees, so sine 45 degrees. We know that the first one's always cosine, second one is always sine. So sine of 45 is this one, root 212. Okay, what about cosine of 8 pi on 3? So we want to work out sine of 8 pi on 3. We can take out 8 on 3 and minus 2, because there's 2 pi radians in a full revolution. So instead of minusing 360 degrees, we are minusing 2 pi radians. So I'm just going to minus 2. So that's technically 2 pi on 3. 2 pi on 3 is here. And because we're looking for cosine, that's equal to negative half. Okay, question 3. Tan of negative 120. I'm just going to add 360 to negative 120, which is 240 degrees, which is right here. Tan is sine on cos. Sine is negative root 3 on 2. Cos is negative half. So the 2's cancel each other. The negatives cancel each other out. I'm left with root 3 on 1, which is just root 3. Okay, question D, we've got cosecant of negative pi on 3. So negative pi on 3, what we're going to do is we're going to get the fraction in front of that pi, which is negative 1/3. I'm going to add 2 pi, but we're just going to add 2 instead of adding 2 pi. So that's technically 5 pi on 3. So where is 5 pi on 3? 5 pi on 3 is right here. So cosecant is the same as 1 on sine. So technically we've got 1 on sine of negative pi on 3. Sine is this one. So because it's cosecant, we need to do the reciprocal of that, which is negative 2 on root 3. Okay, so we just swap them around. Okay, question E, we've got secant, which is 1 on cos. So I'm just going to go to my calculator again. 690 on minus 360. That's 330 degrees, which is this one. So cos is this one. Because it's 1 on cos, I'm just going to flip that final reciprocal, which is 2 on root 3. Okay, last one. Cot. So I've got negative 15 on 4. I'm going to add 2. Oh, it's still negative, so I'm going to add another 2. Okay, so that's the same as pi on 4. Pi on 4 is this one right here. And cot is 1 on 10, which is the same as saying cos on sine instead of sine on cos. So cos is root 2 on 2. Sine is root 2 on 2. And that just equals to 1. Okay. Use your calculator to evaluate these to 3 decimal places. This is pretty easy if you have sine, cos, and tan. If you have cosecant, secant, and cotangent, then you just need to use the fraction button. So let's have a look at the first one. Because these are all in degrees, we need to make sure that our calculator is also in degrees mode. So just be careful with that. Sine of negative 43 is negative 0.682. Okay. Cosecant is the same as 1 on sine. So technically we can just do 1 on sine 807. So 1 on sine 807, 1.001. Okay, secant is 1 on cos. Negative 166, which is negative 1.03. Sorry, 3 decimal places, 31. Cotangent is 1 on 10. .105. Right, now we've got questions in radians. Now whenever we evaluate trig ratios that are in radians, we need to make sure our calculator is in the radians function, or in the radians mode. So to do that, we need to press Shift, Mode. Radians is number 4, so I'm going to hit 4. And now I can do cos of 9 pi on 7, which is negative 0.623. Okay, cotangent is the same as 1 on 10. Okay, so that's 3 pi. So we have 1 on 10 of negative 3 pi on 5, which is 0.325. Cosecant is the same as 1 on sine. .414, and secant is 1 on cos. Which is negative 2. Nice. Okay, and so now you should know how to use your calculator, draw arrays, and use diagrams to write trig ratios. Now, it's also important for you to know how to convert your calculator back to degrees mode. So at the moment it says R for radians. If you need it to be in degrees, because all the questions you have to answer are in degrees, then you need to press Shift, Mode, and number 3 is degrees. So 3. And you're back in degrees because it says it's D. Okay, so it's very important. If the questions are in degrees mode, make sure your calculator is in degrees mode. If the questions are in radians, make sure your calculator is in radians mode as well. Okay, and that's it for this video.